All right, guys, so we've talked about chords, secants, and tangent lines. We've talked about finding the measure of an arc. Now we're going to use chords to find the measure of an arc. So the first theorem we're going to talk about is the congruent corresponding chords theorem, which says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So remember, a minor arc is an arc that is less than 180 degrees, and it goes around the outside of a circle. So there's one minor arc, and here is, your other minor arc. So this theorem says that these two arcs are congruent if and only if their two chords that connect their endpoints are congruent. So in other words, two chords are congruent in one circle or in two separate congruent circles, then their minor arcs are congruent. So in this diagram here, we have circle P and circle Q. Tells us that FG, this chord, and JK, this chord, are congruent. Tells me that the measure of JK, this arc right here, is 80 degrees, and it wants me to find the measure of arc GF. So we know that those chords are congruent. That means their arcs are congruent, which means that the measure of arc GF must also be 80 degrees. Since these chords match, these arcs match. Okay. Second theorem we're going to talk about is the perpendicular chord bisector theorem. It says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So, sorry, I've drawn on here a little bit. So what this says is if the diameter is perpendicular to a chord, and remember perpendicular means it forms a 90-degree angle, then the chord is bisected or cut in half. Remember the word bisected means cut in two equal pieces. Okay, so you can see that this diameter EG makes a right angle with this chord, which means that it cuts it into two equal pieces, and it cuts that arc into two equal pieces. Now, the converse of this theorem, if you don't remember that word, it's the reverse. We switch those if and then statements. If one chord bisects another chord and makes a right angle, then the first chord is a diameter. So let's do some practice here. The first thing it wants us to do is find HK. So it wants us to find the length of this chord. Remember, if the diameter and this chord make a right angle, then this chord is cut into two equal pieces. Since this piece over here is 7, that means that piece over there is 7. So this whole piece is 14. Next, it says find the measure of arc GF. So we're wanting to find the measure of this arc here. That says GF. It should say HK. Okay. Remember, if the diameter forms a 90-degree angle with this chord, then this is cut into two equal pieces, which means that 11x must equal 70 plus x. So now I have an equation, I can find what x is. I'm going to subtract x from both sides here. We end up with 10x equals 70, divide by 10, and x is 7. So the reason I needed to figure out what x was is so I could plug it back in and find the total length of this arc. Okay. So now this piece, instead of being 11x, is 11 times 7, which is x, or 77. And this up here is now 70 plus 7, or 77. So the total measure of this arc is 77 plus 77, which is 154 degrees. Okay. Oops. Okay, next example, it says in exercises 1 and 2, use the diagram of circle D. So if the measure of arc AB, right there, is 110 degrees, find the measure of arc BC, or this piece over here. Okay. So using one of those two theorems from before, we know that this arc AB is the same as this arc BC. They are at the same distance, 9. Okay. So if our chords are congruent, then our arcs are congruent. So if this is 110, this is also 110 degrees. Next, it says if the measure of arc AB is 150 degrees, find the measure of arc BC. Well, same idea, right? Those chords are congruent, so those arcs are congruent. If it's 150, the other one must also be 150. Okay. Next, in exercises 3 and 4, find the indicated length or arc measure. So the first one wants us to find CE. Oops. So find that distance right there. Well, you can see that this diameter and this chord form a 90-degree angle, which means that this chord is cut exactly in half. So if this piece is 5, this piece is 5. So the total length is 5 plus 5, or 10. The same is true for those arc pieces, right? It's cut exactly in half. So if I wanted to find the measure of the arc from C to E, first I need to find out what x is. But I know that 9x, this piece, is equal to 80 minus x on the other side. So now I just need to get x by itself. So 10x equals 80. Divide both sides by 10, and x equals 8. So now I'm going to take that and plug it back in. So this is 9 times 8, which is 72. And this is 80 minus 8, or 72. So the total measure of this arc is 72 plus 72, which is 144 degrees. Okay, very last theorem we're going to talk about. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. That word equidistant, we've seen it before. It means the same distance. Okay. So if two chords are congruent if and only if they are the same distance from the center. So that means that this distance and this distance are the same. So in other words, two chords are congruent, the same length, if the perpendicular distance from the chord to the center are equal. So in this diagram right here, they tell us that QR, this chord, and ST, this chord, are both 16. Tells me that CU, that distance from the center to the chord, is 2x, and CV, the distance from the center to this chord, is 5x minus 9. Wants us to find the radius of circle C. Okay. So the radius is not shown in this picture. The radius we're going to draw in right here from point C to point Q. Okay. Which, if you can't tell, we just drew ourselves a right triangle. So we're going to use that in just a minute here. Okay. First things first, this right here is a diameter. Okay. And it forms a right angle with this chord, which means that this chord is cut in half. And this chord is 16, which means that this piece and this piece are both 8. Okay. So I'm going to draw my right triangle here off to the side. Okay. So far I know that this piece is 8, this piece is 2x, and this piece up here is what I'm trying to find, my radius. So normally I would use Pythagorean theorem, right? But this 2x is throwing me off. I need to figure out what this 2x really is before I can use Pythagorean theorem. So how do I figure out what 2x is? Well, I know that these two chords are the same, which means that these two distances, let me highlight them in green, right here and right here are the same, which means that 2x equals 5x minus 9. So now I can figure out what x is to find this side. So I'm going to minus 5x from both sides. This is negative 3x equals negative 9. Divide by negative 3, and x is 3. Which means that this side over here, instead of being 2x, is 2 times 3, or 6. So now I know two sides of my right triangle. I can use Pythagorean theorem to find the other. Pythagorean theorem, a squared plus b squared equals c squared. My a is 6, my b is 8, and my c is r. So 36 plus 64 equals r squared. 36 plus 64 is 100. Now to get r by itself, I need to square root both sides. And the radius is 10. So even though this was a super crazy picture, we didn't have to do that crazy of work. We needed to figure out what x was, and then we could use that to find our radius. Let's do it one more time. So in this diagram here, we have the information that JK, that chord, and LM are the same size. They're both 24. We know that NP and NQ are also are 3x and 7x minus 12. But we know that they're the same size because those chords are the same size. It wants us to find the radius. So let me draw my radius on here from N to J. Now again, that's only one possible radius, but the reason I'm using it is so I can use a right triangle. So let me draw my triangle on here real quick. We have this side is 3x. We know what this side is even though it's not in the picture because this whole thing is 24. And this is a diameter that cuts it into 2 equal pieces. Each piece is 12. And then this is the piece I want to find, the radius. So before I can find r, I need to find x. But I know that those two green chords or distances are the same. So 3x is equal to 7x minus 12. And I can get x by itself. I'm going to subtract 7x from both sides and divide by negative 4. So x is 3 again. So instead of this being 3x, this is 3 times 3, or 9. And I can use Pythagorean theorem again. My a is 9, my b is 12, and my c is r. So 81 plus 144 equals r squared. That is 225 equals r squared. And the square root of 225 is 15. Square root both sides. Oops. Let's write it the way it's going. And our radius is 15. And that's it. Lots of theorems in this one. So read through them again, look at those examples, make sure you really understand the difference between them.